Hello everyone, I'm Jonel, together with my group mates Milan and Ronald, and we're going to discuss all about embedded database and welcome to Emilian College Incorporated. An embedded database system is a database management system or DBMS which is tightly integrated with an application software that requires access to store data such that the database system is hidden from the application's end user and requires little or no ongoing. Embedded database can be confusing because only a small subset of embedded database products are in use in a real-time embedded system such as telecommunication switches and consumer electronic devices. What are the examples of an embedded database? EmbeddedDBase Incorporated, Berkeley DB from Oracle Corporation, CSQL from csqlcatch.com, Extensible Storage Engine from Microsoft, ExtremeDB from MacObject, Firebase Embedded, HSQLDB from HSQL Unix Server or IDS from IBM, InfinityDB from Boiler Bay Incorporated, InnoDB from Oracle Corporation, RDM Embedded and RDM Server from Raima Incorporated, SolidDB, SQLite, SQL Server Compact from Microsoft, Embeddable Key Value Storage. In this report, we're going to focus on SQLite. What is an SQLite? SQLite is an in-process library that implements a self-contained, serverless, zero-configuration, transactional SQL database engine which is zero-configured. That means, like other database, you don't need to configure it in your system. SQLite engine is not a standalone process like other databases, so you can link it statically or dynamically as your per requirement with your application. It storage files directly. But why should we consider an SQLite? SQLite does not require a separate server process or system to operate, so it means it is serverless. SQLite comes with zero configuration, which administration needed. A complete SQLite database is stored in a single cross-platform disk file. SQLite is very small and lightweight, such as less than 400 kilobytes fully configured and less than 250 kilobytes with optional features on internal dependencies. SQLite also accommodates transactions that are ACID compliant, which means allowing safe access from multiple processes or threads. SQLite supports most of the query language features found in an SQL 92 or SQL2 standard. SQLite is written in an ANSI and provides simple and easy-to-use API. SQLite is available on Unix, such as Linux, Mac OS X, Android, and iOS, and also in Windows such as Win32. A brief history of SQLite. In the year 2000, Richard Heath had designed the SQLite for the purpose of no administration required for operating a program. Also, in that particular year, in August, the SQLite 1.0 had a database manager. In 2011, Heath announced to add the UNQL interface to the SQLite DB and to develop the UNQLite with document-oriented database. Similar to any other databases, the SQLite has its own limitations of the SQL 92 in the SQLite, which are shown below. For example, in the right outer join, only the left outer join is implemented. For the full outer join, only the left outer join is implemented. In a rename table and add command variants of the alter table commands are supported, but the drop column, alter column, and add constraints are not supported. Also, in trigger support, for each row triggers are supported, but not for each statement triggers. View in SQLite are read-only, so you may not execute a delete, insert, or update statement on a view. Similar on a grant and revoke, the only access permissions that can be applied are the normal file access permissions of the underlying operating system. The standard SQL commands to interact with the relational databases are similar as SQL. They are create, select, insert, update, delete, and drop. The commands can be classified into groups based on their operational in nature. For example, in terms of language, the commands are create, which is used to create a new table, a view of a table, or other object in the database. The second one is alter, which is used to modify an existing database object such as a table. And lastly, the drop command, which is a view of a table or other object in the database. When we talk of the DDL, it pertains to creating the structural part of our database. But please be careful of using this particular command such as the drop, because if you drop a particular table or a database, there is no point of returning it previously. The data manipulation language, or the DML. It consists of commands that are used in managing the content of the database, such as insert, which is used to create a new record, update, modify the record, delete the record, and the DQL, or the data query language, which consists of certain records from one or more tables in the database. Before we proceed in an SQLite syntax, there are things that we must remember. Number one, case sensitivity, or the sensitivity of the text. The important point to be noted is that in SQLite, it is, but there are some commands which are case sensitive, like the uppercase glob and then the lowercase glob, which has a different meaning in the SQLite statement. The second one is more on comments. SQLite comments are the extra notes which you can add in your SQLite code to increase its readability, and they can occur including inside expressions and in the middle of the other SQL statements, but they cannot be nested. How can we create a comment inside our code? For example, this is a single line comment. It must be initialized by a double dash. The second one, this is a single line comment, such as using backslash asterisk inside a comment or write a comment. Then the second one, or lastly, asterisk, then followed by backslash. The SQLite statements. All the SQLite statements start with any of the keywords like select, insert, update, delete, alter, drop, and etc. And all of these statements ends with a semicolon. For example, if we want to code an analyze statement, we can use analyze followed by the semicolon, or analyze space specify the database name followed by a semicolon, or analyze space specify the table name dot specify the table name. But what is an analyze command? The analyze command gathers statistics about the tables and indices and stores the collected information in an internal table of the database where the query is processed. The second one is the SQLite, and usually these particular clauses are used in a select command. For example, select space, specify the first column, space, specify the column name, next, going to the last column, separated by a comma, from, specify the table name, space, middle, specify the end or the or clause, and then followed by the second condition, terminated by a semicolon. If we're going to use the end, this particular command matches the first condition and the second condition on the records of the database. However, if we're going to use the OR, it matches either of. The next one is the SQLite alter table statement. For example, if we want to use this, we can directly type alter space table space table name space add space column space specify the column definition, then terminated by a semicolon. This particular line of code can be used in adding a new field in the database or specifically in our table. The next one is the SQLite alter table statement, or we can consider this as a rename. We can use this by using this particular code, alter space specify the table space rename space to space the new table name that you wanted to rename to our previous table name. The next one is the SQLite attach database statement. We can use this particular code by using the following code. For example, attach space database specify the database name space as specify the alias name. But what do we mean by attach database? The attach database is a statement that adds another database file to the current database connection. The database file using the detach database command that we're going to discuss later on. And the SQLite begin transaction statement. We can use this particular command by typing directly the keyword begin, then semicolon, or begin space exclusive space, then followed by a semicolon. SQLite between clause. Example, select space column number 1, comma, column number 2, going to the last column, separated by a comma, space, from, space, specify the table name, space, where, space, between, space, specify the first value, and specify the second value. This particular line of code searches a particular record in the database with a value which ranges in the between of the value. The second one or the next one is the SQLite commit statement. The code is commit, then terminated by a semicolon, followed by SQLite create index statement. In creating an index statement, the code is create space index space space on specify the table name, then open and close parentheses and close, specify the column name, and collate, no case, and terminated by a semicolon. For example, if you wanted to create a unique index statement, the code is create space unique, specify the index name, space on, space, specify the table name, space, open and close parentheses, then specify the first column going to the last column. The next one is the SQLite create table statement. The create table in the database. For example, create space table space specify the table name, then open and close parentheses, enclose, specify the column definition such as the column name, the data type, and then the attributes such as a primary key, and terminated by a semicolon. The next one, statement. In creating a trigger statement, the code is create space trigger space database name dot specify the trigger name space before space insert space on specify the table name, then the transaction. For example, the first statement semicolon, the second statement semicolon, going to the last or to the end of the trigger command. This particular line of code will activate only if the trigger operation or the trigger event has been encountered by the database. The second or the next one, statement. In creating a view, the code is create space view space specify the database name dot specify the view name space as space select, then specify the statement. The view statement is the code or a code that is used in creating table but not necessarily existing. The next one is the SQLite or creating a virtual table statement in an SQLite. The code or the example are the following. For example, create space virtual, specify the database name, dot, specify the table name, space, using, for example, a weblog, and enclosed in a parenthesis, specify the access.log, and then terminated by a semicolon. Or, you may type create space virtual space table name using the FTS3 open and close parenthesis. But what is a virtual table? A virtual table is an object that is registered in an Open SQLite database connection from the perspective of an SQLite statement. A virtual table is to an external storage or a computation engine that appears to be a table but does not actually store information in a database file. Then, followed by the SQLite commit transaction statement, which is the code is commit. SQLite count clause. The code is select space count, open and close parenthesis, specify the column name, from, specify the table name, where, specify the condition. This particular function counts the record name. The next one is the SQLite delete statement. The code is delete from, specify the table name, space, where, specify the condition. But be careful in managing the delete. Running the delete command without a condition literally deletes all the rest. The next one is the SQLite detach database statement. The code is detach space database and specify the alias name. In detaching or the detach database statement automatically removes the connectivity of a connected to the present or to the current database that you are using. The next one is the SQLite distinct clause. The code is select space distinct space column number 1, comma, column number 2, going to the last column from the table name. The distinct clause search record from the specified column names. The next one is the SQLite drop index statement. The code is drop space index space database name dot index name. Next, SQLite drop table statement. Drop space table name dot table name. The next one is the SQLite drop view statement. The code is drop space index space database or specify the database name dot specify the view name. The next one is the SQLite drop trigger statement. Index space specify the database name dot specify the trigger name. This particular code literally drop or remove the specified object in the database. The next one is the SQLite statement specifically exist or the exist clause. Column number 1, comma, column number 2, going to the last column from specify the table. SQLite exist clause. The code is select space column number 1 space column number 2 going to the last column space from specify the table name space where specify the column name space parenthesis then specify your second query which is select for example asterisk space from then specify the table name. This particular line of code matches if there is an existing record from the first query going or from the first table going to another table. And the code is explain space insert space statement terminated by semicolon, or explain, space, query, space, plan, space, select, space, statement, terminated by a semicolon. The next one is the space, select, space, specify the first column, going to the last column, separated by a comma, then from, specify the table name, where, specify the column name, then the code glove, and specify the pattern that you want to search. The next one is the SQLite group by clause. For example, using the sum function, specify the column name, from, specify the table name, where, specify the condition or the condition, group by, specify the column name. The group by clause usually groups a particular record based on the statement given. The next one is the code is select, for example, using again a sum function such as open and close parentheses, specify the column name, from, space, specify the table name, space, where, specify the condition, space, group, space, by, space, specify the column name, parentheses, specify the arithmetic function or the condition that you want to be enclosed in the select or into a query. The next one is the SQLite insert into statement. The code is insert, space, into, space, specify the table name, open, going to the last column, then space, specify the values, space, open and close parentheses, then specify the first value going to the last value. Be careful in the arrangement of the column that must be equal with the arrangement of the values. The second one is the SQLite in clause. Specify the column or the first column, comma, going to the last column, from, specify the table name, where, specify the column name, in, open and close parentheses, specify the first value, the second value, going to the last value. The in clause usually search a particular record in the database with the specified in clause values. The next one is the SQLite like clause. The code is select, space, column number 1, space, going to the last column, from, specify the table name, where, specify the column name, like, specify the pattern. Either or even in a form of uppercase or in a form of lowercase. The next one is the SQLite not enclosed function or clause. The code is select, space, specify the first column, space, specify the second column, from, specify the table name, space, word name, not in, open and close parentheses, specify the first value going to the last column. It means it is the opposite of the in. It means searching a particular record that doesn't match in a given value. The next one is the SQLite order by clause. Specify the first column, space, specify the second column, going to the last, from, specify the table name, where, specify the condition, order by, specify the column name, even though in a form of ascending or descending. The next one is pragma, space, pragma name, terminated by semicolon, space, or next is pragma, space, page size, or pragma, space, specify the cache size, for example, 124. The next one is pragma, specify the table information, opening close in a parenthesis, with table name inside and terminated by a semicolon. The next one is the SQLite release save point statement. The code is release space save point underscore name. This particular code literally backtrack of a particular file in the database. The next one is the SQLite reindex statement. The code is reindex space collision underscore name or reindex space specify the database name dot index name or reindex dot table name. SQLite rollback statement. The code is rollback terminated by a semicolon rollback space to space save point space specify the save point name and terminated by a semicolon. This code can be used for restoring a database. The next one is the code is save point space specify the save point name. This code can be considered as the backup of or a code for creating a backup of a database. The next one, SQLite select statement. The code is select space specify the first column specify the table name used for querying or searching a particular record. The next one is the SQLite update statement. The code is update space table or specify the table name space set specify the column and its value going to the last column in button used for updating a particular record in a database. The next one is the SQLite vacuum statement. The code is vacuum. The next one is the SQLite where clause. The code is select space specify the first column going to the last column from where specify the condition. The where clause literally searches or use as a condition to search inside a database. The next one is the SQLite data type. The SQLite data type is an attribute of a data of any object. Each column, variables, and expressions has a related data type in SQLite. The SQLite uses a more general dynamic type of system. In SQLite, the data type of a value is associated with the value itself. For example, in storage class, our first is null. The description is the value is a null value. The next one is an integer. The value is an signed integer stored, for example, in 1, 2, 3, 4 going to 8 by the value. The next one is real. The value is a floating point value stored in an 8-byte IEEE floating point number. The next one is text. The value is a text string stored using the database encoding such as UTF-8, UTF-16BE, or and lastly the blob. The value of a blob data is stored exactly as it was the input. For example, in an integer, we can use int, integer, tiny int, small int, medium int, unsigned big int, int2, and int8. The next one is text. For example, character 20 or number of characters to be saved 20, bar character up to 255 characters. Next, varying character up to 255 characters, native character to 70 characters, and varchar to 100 characters, text, and club. The next one is none. For example, the blob, which has no data type specified. The next one is real. For example, real, double. The next one is numeric. For example, numeric, decimal. For example, 10, 5 specifies the number of places and then the number of decimal points. Then the next one is boolean, date, and date and time. In data type, it does not have a separate boolean class or storage class. Instead, the boolean values are an integer, for example, 0 for false, data type, and 1 for true.
For example, boolean.
In date and time data type, the SQLite does not have a separate storage class for storing dates and or time, but SQLite is capable of storing dates and time.
Data type, the SQLite does not have a separate storage class for storing the dates and or the times, but SQLite is capable of storing dates and time as text, real, or integer. So you can choose to store dates and time in any of these formats and freely convert between formats as stated below for text, real, and integer. The next one is operators. An operator is a reserved word or a character used primarily in a SQLite statements word clause to perform operations such as comparison and arithmetic operations. Operators are used to to specify conditions in an SQLite statement is to serve as conjunction for multiple conditions in a statement. For example, arithmetic operators, comparison operators, logical operators, and bitwise operators. Examples of arithmetic adds the value on either side of the operator. Subtraction, which subtracts the right-hand operand from the left-hand operand. Multiplication, which multiplies values on either side of the operator. Division, which divides the left-hand operand by the right-hand operand, the left-hand operand by the right-hand operand, and returns the remainder. In terms of comparison operators, let's assume that we have a variable a that holds 10 and variable b that holds 20. Operator, for example, such as equality, in a sense of double equal or the value of two operands are equal or not. Based on our example, it will return a not true or a false answer. The next one, for example, is an exclamation and an equal symbol which pertain to not equal, which in our example, it will return a true value. Then exclamation and equal is somewhat or equally the same with a less than and a greater than symbol enclosed to each other. The next one is a greater than symbol. The greater than symbol checks if the value is greater than the value. Similar with the less than condition, or as an opposite of the greater than is the less than condition, which checks if the value of the left-hand operand is less than the value of the right-hand operand. The next one is greater than or equal, which checks if the value of the left operand is greater than or equal to the value of the right-hand operand. If yes, then the condition becomes true, and the opposite is the less than or the greater than or equal. In logical operators, here is the list that we can call AND. The AND operator allows the existence of a multiple condition in an SQL statement where clause. It checks both the condition left and right. The next one is between. The between operator is used to search for a values that are within a set of values to the maximum value. The next one is exist. The exist operator is used to search for a presence of a row in a specified table that meets the certain criteria. The next one is in. The in operator is used to compare a value to a list of. The next one is the not in. The negation of in operator, which is used to compare a value of to a list of literal values that have been specified. Also, we can use the like, which checks the operator to compare a value to a similar value using the wildcard. The next one is the glove. The glove operator is used to compare a value to a similar values using a wildcard operator. Also, glove is a case sensitive and like. The next one is the not. The not operator reverses the with which it is used. For example, not exist, not between, not in, and etc. This is to negate the operator. The next one is the OR. The OR operator is used to combine the multiple conditions in an SQL statement where clause. Null. The null operator is used to compare a value with a null value. And the next one is. The is operator works like equal. If not, the is operator works like not equal. And adds two different strings and make new one. And the next one is unique. The unique operator searches every row of a specified table for the uniqueness. It means there must be no duplicates. In terms of a bitwise operator, bit by bit operation, the truth table for ampersand and a pipe sign is as follows. The first one, the ampersand. Binary AND operator copies a bit to the result if it exists in both operands. The next one is the pipe sign, or copies a bit if it exists in an either operand. The next one is a binary ones complement operator that is unary and has the effect of flipping bits. The next one is a binary leap shift operator. The left operand value is moved left, and the next one is the binary right shift operator. The left operand value is moved right by the number of bits specified by the right operand. That's all. Thank you. Our references are http